The universe is a vast, beautiful expanse filled with stars, galaxies, and planets. But what if we told you that everything we see, everything we know, makes up less than 5% of the universe? The rest? It's a mystery. Something invisible, powerful, and unseen is holding it all together. This elusive force is known as dark matter. Today on Knowledge Hub, we're diving deep into the enigma of dark matter, the invisible glue that binds the cosmos, and how it might hold the key to understanding the true nature of the universe. In the 1930s, astronomers made a puzzling discovery. As they studied galaxies, they noticed that these massive structures were rotating much faster than expected. According to the laws of physics, galaxies should have been torn apart by their own rotation. There wasn't enough visible matter, stars, planets, and gas to generate the gravity needed to hold them together. So what was stopping them from flying apart? This is where dark matter comes into play. It doesn't emit, absorb, or reflect light, which means we can't see it directly. But we know it's there, because we can see its effects. Dark matter creates the extra gravity that holds galaxies together, like an invisible web stretching across the universe. But what exactly is dark matter? That's the million-dollar question. Despite decades of research, scientists are still in the dark. We know that dark matter makes up about 27% of the universe, far more than the ordinary matter we're familiar with. But it doesn't behave like anything we've ever encountered. It doesn't interact with light, and it barely interacts with normal matter. Yet, without it, galaxies wouldn't exist as we see them today. There are several theories about what dark matter could be. One leading idea is that it's made up of particles that are completely different from the protons, neutrons, and electrons that make up ordinary matter. These particles are called WIMPs, or weakly interacting massive particles. If WIMPs exist, they could explain the extra mass that holds galaxies together. But so far, they've evaded detection. Another theory suggests that dark matter could be made up of axions, tiny particles that have no charge and incredibly small mass. While scientists have been searching for these elusive particles in experiments all over the world, dark matter remains hidden. Still, its fingerprints are everywhere. One of the most significant clues comes from studying the cosmic microwave background, the afterglow of the Big Bang. By analyzing this ancient radiation, scientists have been able to map the distribution of dark matter across the universe. It shows up as massive, invisible scaffolding, helping to form galaxies and galaxy clusters over billions of years. But dark matter's influence isn't limited to the distant past. Even today we can observe its effects in galaxy clusters where entire galaxies are moving in ways that defy explanation. Unless you account for dark matter, it's like an invisible force field, quietly shaping the cosmos while remaining out of reach. And while dark matter doesn't interact with ordinary matter in any significant way, its gravitational pull is undeniable. It has sculpted the large-scale structure of the universe, forming a cosmic web of dark matter that stretches for billions of light years, linking galaxies and galaxy clusters like cosmic highways. So if dark matter is everywhere, why haven't we found it yet? The answer lies in its elusive nature. Since dark matter doesn't emit light or energy, we can't observe it directly. Instead, scientists are building detectors deep underground, in the hopes that a passing dark matter particle will interact with ordinary matter just enough to leave a signal. But so far, these interactions have been rare if they've happened at all. The search for dark matter is one of the greatest challenges in modern physics. It has the potential to revolutionize our understanding of the universe and maybe even lead to new discoveries in particle physics. If we can crack the mystery of dark matter, we could gain insight into the very building blocks of the cosmos and learn more about the forces that shaped everything around us. But for now, the true nature of dark matter remains just out of reach, an invisible puzzle that holds the universe together, waiting to be solved. While we may not fully understand dark matter yet, its presence reminds us of how much we still have to learn about the cosmos. The universe is a place of wonder, full of mysteries waiting to be unlocked. And the search for dark matter, it's just the beginning of our journey to understand the invisible forces that shape our reality. Thank you for watching Knowledge Hub. If you enjoyed exploring the mystery of dark matter with us, don't forget to like, subscribe, and hit the bell icon for more cosmic content. Until next time, keep wondering about the universe, because the more we learn, the more incredible it becomes.